Life has become more difficult or easier after joining the geography classes? It is becoming easier or difficult? Honestly, हाँ फिर ठीक है. For some of you, I understand that may have become difficult also, है ना? Only when you are learning the concepts for the first time. ठीक है? हाँ, keywords. अब मैं उसको क्या करूँ बताओ? मैं यूज करने पड़ते ना. Unusual बोलो. Okay, ठीक है. Right. Yes. So we are done with the winds. The last chapter that we are left with in the climatology, that is, we are going to see now the moisture. Then for the prelims, however, it has not been asked, but still I will discuss this stability and instability conditions of the atmosphere. Then we'll talk about what is the absolute humidity, what is the relative humidity, and the clouds I will leave intentionally. I think in your handout, clouds are given. So cloud is very simple. I will discuss very briefly and कुछ नहीं है उसमें, ठीक है? So we'll see that very quickly. We'll glance through that. And finally we will see in this chapter, see here. The most difficult geographical parts are over. Now very easy the geography is, right? Now see here. While I said that, I am not smiling. ठीक है? Number one, it is, see here now. We are going to see now what is atmospheric moisture, or rather I will use the word humidity. Humidity, right? Clouds, condensation, and rainfall. Rainfall, when I say the rainfall is of three types, one is known as convectional, second is orographic, and third would be cyclonic or frontal. This is the one part that we are going to discuss. The second part, then we will enter into air masses and fronts. Air masses and fronts, and then we'll talk about various types of the fronts. Then we are going to talk about cyclones. That is, after air mass, rather I would discuss thunderstorm and tornadoes. And then we'll talk about cyclone. And the cyclones are of two types, temperate and tropical. So this will nothing but result in end of your climatology, right? With this, we will finish the climatology. Now see here, what is the importance of this chapter? You can expect one question from here also, that is in this chapter, and one question for sure from this area. If you are lucky enough, 2 to 3 questions can go in this area. For example, they can ask you something about thunderstorm, something about tornadoes. Then they can also ask you something about temperate and tropical cyclones, right? So that area is now again important. So one that we are starting with, first I am coming to atmospheric humidity, clouds and condensation. Now see here. See here. First is humidity. So humidity is of three types, right? So one is known as absolute humidity, not three type. I will discuss two type of humidity. Number one is absolute humidity. Absolute humidity. विष्णु एक बोतल ले आओगे खाली या थोड़ा सा पानी भर के, बिस्लेरी वाली. Absolute humidity. Second, humidity capacity. And third is going to be relative humidity. The well-defined definitions are given in your handout. I am just explaining here. Okay, see here now, one by one. If I consider that this is the air pocket, any of the air pocket, and in this air pocket right now, okay, right now in this air pocket, I am assuming, see here, I am using the words for making this simple as ml. Okay, otherwise this is volume. Volume should be measured in what? Gram per centimeter cube or meter cube, right? So I am assuming simple terms. For example, I am using this term that the water vapor content which is here right now, it is, I am using the term intentionally, I am using this ml. However, it is not measured in ml. Okay? Intentionally I am using word ml. I am saying this air pocket has total capacity that it can hold 1000 ml. Right, but instead of going into what is the capacity, right now we will observe only what thing, that is how much it is right now have. समझ में आया? So right now at one particular temperature, amount of moisture available in an air pocket, it becomes your absolute humidity. Got it? Hello? Yes. Now see here. Humidity capacity. What is humidity capacity now? Please understand. Humidity capacity is, it is the capacity of an air pocket to handle the moisture, or to pocket to handle the moisture. Capacity of an air pocket to handle the moisture, or holding the moisture, rather holding the moisture, handle or holding the moisture. Now for example, it is at sea, which will be directly dependent on the temperature of the air. And if the temperature is more, what will happen to the humidity capacity? It will increase. Now say here, the third one, now say here, third one. What is relative humidity? I will not go into formula. Rather than that, we will derive this formula. So here, for example, suppose we had that air pocket. How much it was the capacity? 100 ml. It means, can I say this is nothing but humidity capacity? Yes or no? 100, sorry, this 1000 ml, with our example, this was the humidity capacity. It means how much it was maximum it can hold. Yes or no? Yes. Now see here, out of 1000 ml of HC, how much of the moisture right now is present? 100 ml. It means in terms of, let's say, percentage, if I ask you, how much amount of, let's say, saturation is there in terms of water vapor, how much it is saturated? It is only 10%. Yes or no? Yes. If I say the relative humidity is nothing but it is the measure, that is how much your air pocket is moist or humid. Now see here, can I say right now, if we derive this relative humidity according to your formula, you must have used 100, 1000, and then you must have multiplied with the 100%. ऐसे ही निकाला ना? Yes or no? Yes. Can I say in that way, that is, if I talk about this 100 ml, what is this 100 ml? I'm just writing the relative humidity. What is 100 ml? Can I say this is absolute amount of what? Absolute humidity of the cloud? Yes or no? Or the air pocket? It is divided by what? What is this 1000? Capacity of the air. So this is humidity capacity. Humidity capacity. And then if it is multiplied by what? If it is multiplied by 100, and it is now percentage. समझ में आया? Yes. So what is the absolute humidity? What is the relative humidity? Please understand. Right now, how much of the moisture the air pocket has? This is absolute amount of moisture I'm talking about. Absolute humidity. Humidity capacity means how much of the moisture the air pocket can hold. That is humidity capacity. Third is known as absolute humidity divided by the humidity capacity. Do not try to ratify this formula. Just understand in that way. 100 ml is the moisture. 1000 ml is the total capacity. So at how much percentage of its capacity it is right now? At 10%. So कैसे निकालोगे? Relatively it is only 10% saturated. So this is how you can derive, right? Can I now, if I want to understand relative humidity, can I write in this way? Relative humidity can also be written in this way. Can I say this can be written if I replace this humidity capacity with temperature? What is the relation between humidity capacity and temperature? Direct. Can I say relative humidity will be written then in this case absolute humidity and divided by what? Temperature? Yes or no? I am just putting here temperature because humidity capacity is proportional to temperature. Now see here. Please remember one thing. For any type of rainfall to occur, you need fully saturated air pocket. When I say fully saturated means it must have 1000 ml of the moisture. Means it must be operating at 100% of RH. Now please remember this one. For any precipitation to occur, for any precipitation to occur, what is required? RH must be 100%. This is, you will remember. Okay, RH must be 100%. That is relative humidity. Okay. Now see here, if you want the precipitation or the rainfall, it means now you need this 100% of RH. Okay. Now see here, for any type of precipitation to occur, do you remember two conditions I mentioned? Tell me. For any type of precipitation to occur, these are the two basic conditions. Number one, warm and moist air. Then it's upliftment. Okay, it's upliftment. This is the minimum two conditions. Upliftment. This is the two basic conditions. Now please understand. See here. With this example, you will learn. See here. This is the cloud. Okay. In this cloud right now, if I say this is the air pocket, what is the humidity capacity? How much of the moisture it can hold? 1000 ml, right? Right now it is at 500 ml. How much of the moisture, that is absolute humidity, it has? 500 ml. Now, can you tell me what is the relative humidity? It is 50%. Now I want rainfall or the precipitation from this bottle. How it is possible? Now there are two possibilities. Number one, see here, right now in our example, we have 100 ml of the moisture and we have 1000 ml of what? The humidity capacity. If you want to reach to the 100%, you have to add further moisture here so that it will become 1000. So what we will do in that case, we will add more amount of water vapor here. Yes or no? Yes. But for example, see here, for example, this is the water. If I will add and if it will reach to the saturation, then what will happen? It will flow out. Samajh mein aaya? The second position, that is, we do not have the moisture or the humidity, but I have one thing. What is that one thing? For example, if I am decreasing the temperature, then relative humidity can be increased. Yes or no? Yes. Now see here, with upliftment, what will happen to the temperature? With upliftment, temperature will increase or decrease? It is going to decrease. If the temperature is decreasing, what will happen to the humidity capacity? It is going to decrease or increase? It is going to decrease. Now see here, this is the bottle. I have not added any amount of water, but I want rainfall from this one. So if I am uplifting, it is cooling. And because of the cooling, it will contract or expand? It is going to contract. Okay? Or it's rather than this contraction and expansion, because adiabatic cooling mein aapko doubt ho jayega. Just remember in that way, its capacity will decrease to hold the moisture. So now when it is going up, the temperature is reducing, the bottle is now reducing in terms of holding the moisture capacity. Now what happens is, further if it is uplifted, now see here, if I am further uplifting, what has happened now? The bottle has reached to 100% of its relative humidity. And now if now it is further uplifted, what will happen then? It is the amount of moisture will come out, that is your precipitation. Got it? So we have two things. Number one, either you must have to have the absolute amount of moisture that you can add, or if you do not have the moisture to add, then you have to uplift this air pocket for the greater heights. Samajh mein aaya? Then only this relative humidity will reach to 100%. Now the 2-3 things that you have learned, now see here. For example, see here. For example, now here we have, this is the same air pocket. Here it is 100 ml of the moisture is there. Its capacity, let's say 1000 ml. If I am uplifting this, for example, this is mountain. So along the mountain, when it is uplifted, what will happen to the temperature of this air? It will decrease. The air will become colder. If the air is becoming cooler and colder, what will happen to humidity capacity? Its capacity to hold the moisture will decrease. For example, after reaching to this stage, it is now left with only 500 ml of the capacity. How much of the moisture is there? 100 ml. Further, if it is uplifted here, now the cloud, the air pocket is left with very small capacity, that is 200 ml. Is it saturated? Still no. If it is further uplifted, now here, the 100 ml maximum it can hold. And how much of the moisture is there? 100 ml. It means now further if it is uplifted, then what will happen? It will, the additional water will come in the form of what? Precipitation or rainfall. Samajh mein aaya? So therefore, these two conditions are necessary. Number one, you must have to have warm and moist air. and then we will uplift that. That is how the rainfall is going to occur. Yes, everyone? Yes. Now see here. Some more technical point. This is the reason where the air became saturated. Can you see that? The air became saturated here. Air saturation. Now, can you tell me the air saturation will occur at the same height for every type of cloud, or the height will vary according to the moisture condition? According to the moisture condition. For example, if you have more moisture, saturation can occur up to here also. If you have very less moisture, then saturation will require greater upliftment. Yes or no? Yes? Hello? Yes, na? Now see here, the saturation when occurs, the relative humidity when it reaches to 100%, the temperature at which it will occur here. What is the temperature of the air pocket? That will be known as dew point. Dew point temperature. Yes? And after the saturation, now see here. First, when it is water vapor, please understand this. Please understand this carefully. This is water, that is liquid. If you want to convert this into water vapor, you need to give some heat. Yes or no? We have given some heat. Water converted, this is liquid, into what? It is now converted into water vapor. This water vapor is gaseous form. Yes or no? Yes. If you want to convert this back into again liquid, what is required now? Because it is having the latent heat inside, that is known as latent heat of vaporization. If you want to convert this back into what? Into the liquid water, you have to release this heat back. Until and unless it has this heat, it will remain in the gaseous state. So what happens is, if the latent heat is released, so latent heat, if it is released, it will be known as latent heat of what? Condensation. Why? Because of cooling, this can happen. So this will be released and it will again come back to what? Liquid stage. Samajh mein aaya? If you are giving the heat is there, then it is water vapor, gaseous. If the water vapor is releasing the heat, latent heat of condensation, it will again come back into what? Droplet. That is water form in liquid, right? Now see here. If we were uplifting, see here, and the saturation has reached here, or the saturation, let's say after the saturation, what will happen? The further cooling will lead to the formation of what? The condensation will occur, and after the condensation, clouds will form. So what is cloud? See here. What is cloud? It is nothing but because of the cooling, the aggregation of the water droplets. See here. After cooling, water vapor. See here. Water vapor after cooling, what will happen? The water vapor will release latent heat of what? Condensation or vaporization? Latent heat of condensation. And after then, it will convert in water droplets around hygroscopic nuclei. This mini water droplets will be formed. And see here. See here now, if I remove this diagram, see here now. And if, see here, this is the surface. And here, if it is the cloud is forming, see here. What is cloud? Nothing but aggregation of, I'm writing here, aggregation of numerous tiny water droplets and ice particles suspended in air. Okay, this is known as cloud. What is cloud? Aggregation of n number of tiny water droplets. The water droplets, when I say, it is liquid. It is not, I am saying water vapor. Water vapor will convert into what? What is condensation? Condensation is the process in which water vapor will convert into what? Water droplet. Droplet. And this is the process of what? Condensation. Okay. So this is how the condensation will occur, and after only saturation, the condensation will occur. Samajh mein aaya? And then clouds will form, and after the cloud formation, your precipitation and the rainfall can start. Okay. So this is the process. Now, if we learn about the cloud, it is in your handout. You will flip the handout for the clouds. See here. Clouds, if I explain. Clouds are defined in two ways. Number one, based on height. Second, based on shape. Based on shape, if they are horizontal, thin sheet. So sheet-like, they will be known as stratus clouds. Stratus. If they are vertical and this kind, cumulus type, wool-like, they are known as cumulus. Cumulus. And if they are bearing rainfall, so we will use the word nimbus with them. Nimbus means they will cause rainfall. So we will call this cloud, the one that is stratus, we will call then, if it is causing rainfall, then this will be known as, what is this name now? Nimbostratus. And if it is the cumulus which is causing the rainfall, so we will use the word cumulonimbus. Based on shape. Okay? Based on shape, they are majorly two types. That number one, sheet-like, and second is cumulus or the wool-like. Okay? Vertical they are. They are horizontal, they are vertical. Okay? Number one. Number two, the second classification is based on at which height they are forming. So height base in your handout, just see there, 3 type of clouds would be there in your handout. Nimbus. Huh. Now see here, there will be 3 types based on the height from surface to 2.5 kilometer, then 2.5 to 6 kilometer, and more than 6 kilometer. Can you see that? Yes, 3 kind of clouds are there. Let me show you them. Done this with this work. No. See here. These are the 3 type of clouds that is based on the altitude. Now see here. If they are forming, see here, if they are forming in the up to 2.5, they are lower clouds. If 2.5 to 6, they are known as mid clouds or alto clouds. And beyond that, they will be known as high cloud. Can you see that? So this is the 3 type of cloud. Now see here, in this one, please understand the shape. If you will see, what is the alto means? Mid, at the mid. Stratus means, can you see? This is sheet-like. Yes or no? Yes. Then what is cumulus? This is kind of wool-like cloud. They are known as cumulus cloud. Can you see that? In the more than 6.5 kilometer, they are known as cirro cloud. So if the cirro are this one sheet-like, then they will be known as cirro stratus. If the cirro are like this wool-like, they will be known as cirro cumulus. If they are feather-like, like the feather of the bird, then they will be known as simple cirrus cloud. Yes. See here, high clouds are not associated with the rainfall. Okay. The second type of cloud, see here, altostratus and the altocumulus, they are the mid cloud. The same type of clouds can be found in the lower atmosphere, that is stratocumulus because of their shape, and nimbostratus because they are causing rainfall. Can you see? This is the shape and it is causing rainfall. Okay, the clouds are mentioned in your handout. There is nothing much in the clouds, just simply you have to read. Padh loge? Some points I have given you. For example, can you see out of some clouds, some sun shining is coming out. Sun is shining and it is creating halo effect in your handout. Which clouds are they? Cirrostratus. Now what happens is, behind the cirrostratus, if the sun is there, it will glow because it is ice crystals at this height. So because of that, it is going to create this halo effect of the sun. It will be very colorful, bright type of this appearance will come, and that is known as halo effect. Okay? Okay. Clouds, will you be able to handle? Yes, simple. They are very simple. Okay. So that is the cloud. The one important cloud that I will discuss much in detail in the thunderstorm, in the cyclone, that is going to be the one which will be forming right from near the surface up to the troposphere. That is known as, what is the name? Cumulonimbus cloud. That is very important. That is we are going to discuss much in detail. Okay? We will see that. शीट ही तो है. हाँ, तो शीट मतलब आप क्या सोच रहे हो? इतनी सी पतली सी शीट मतलब they are more elongated lengthwise. They will be more vertical. they are more horizontal. Sheet-like means they are more horizontal, and vertical means they are going up and down. Okay, vertical expansion. Now come back after these clouds are discussed. Now see here, the one more concept that I want to discuss is the two kind of lapse rates are there. So one lapse rate that we have discussed, see here now. Now see here, the one is known as environmental lapse rate. The second is known as environmental lapse rate, or you have learned this one, normal lapse rate. Okay. The second side I'm writing adiabatic lapse rate. They are also given in your handout. Everything I have mentioned, just understand here on the board, everything is given in your handout. Okay, see here now. It is given, na? It is given, right? Now see here, please see here. Environmental lapse rate that you have learned, 6.5 degrees C on an average per kilometer. What happens is the air will become cooler. Not air, the atmosphere will become cooler. Now see here, this is the surface of the earth. I am going to 1 kilometer altitude wise. I'm not talking about the movement of air. I simply reached here. What I found that the temperature here, some around 6.5 degrees C was lesser than the surface temperature. Then I reached here. I found further the temperature was 6.5 degrees C, further lesser. So in that case, ELR or NLR, I am not talking about movement of air. I am simply going into various layers altitude wise, and what I have noticed that temperature is decreasing in the static layers of the atmosphere. Why it is decreasing? All 1, 2, 3, 4, 5 factors were responsible. Can you tell me now? Why with altitude temperature decreases? 1, yes, 2, 3, 4, 5. And that rate is your ELR or the normal lap rate. So with altitude, temperature decreases on an average 6.5 degrees C. That is your NLR. Now come to this side. Now what is happening in this atmosphere? We are not worried about that. Now we are focusing on what? In this atmosphere, if the air pocket, some air is rising, what will happen if it is rising? Tell me, what will happen? It will expand. If it is going to expand, what will happen to its temperature? Temperature will reduce, yes or no? Yes. Now see here, if in the same environmental conditions, air pocket was going up and its temperature was decreasing for 1 kilometer by 10 degrees C. Now see here, environment is cooler, that is 6.5 degrees C. Near this environmental air, it is only 6.5 degrees C temperature was reduced. But when it comes to this air, after moving 1 kilometer, the temperature dropped by how much? 10 degrees C. समझ में आया? इसमें क्या समझ में नहीं आया? Air, if it is going up, it is losing the temperature. Why? Because it is expanding. खिचड़ी बनाते हो, फैलाते हो ना? What will happen to that? Temperature will come down. So now air, that is warm air, it is going up, it is expanding. Because of the expansion, temperature will come down. Now see here, what is the difference between the two? In this, I am saying after 1 kilometer, what is the temperature of atmosphere? In this case, I am talking about the temperature of what? The air, not the atmosphere. This temperature is known as adiabatic lapse rate. समझ में आया? Yes or no? Yes. So what is environmental lapse rate? It is all about static atmospheric condition. What is adiabatic lapse rate? It is all about moving air. How much of the temperature is increasing or decreasing of the moving air? Now see here, please understand carefully. See here, what is the adiabatic means? The name itself, what is the meaning? See here, for any type of cooling to occur, there are two methods, right? There are two methods. One is you can remove the heat by cooling that with the help of ice or something. कर सकते हो? Yes. The second is I can spray it. For example, the same example, if I take khichdi, either you can spray that or also you can bring in some ice particles. They can be touched in close contact. What will happen? Your khichdi will become cooler. Yes or no? Two methods are there. In one method, when I was not using ice, simply when I sprayed it and the temperature was falling down, that method is known as adiabatic process. What is adiabatic process? Now learn this carefully. When I am not adding or removing heat content, rather I am just decreasing and increasing the temperatures mere with this expansion and the contraction of the volume. That is your adiabatic process. Can you understand that? Yes or no? Yes. Now see here, if the air is moving up, see here, if the air is moving up, will it expand? If it is expanding, what will happen? This is adiabatic cooling or adiabatic warming? That is adiabatic cooling. The same air, if this is sinking down, it will contract or it will expand? It will contract, and its temperature is bound to increase. And then we will say it is what? Adiabatic warming. So what is adiabatic word? Have you understood? I am not removing heat. I am not adding heat. Here I have not removed heat. I just simply expanded this air pocket. And that is your adiabatic cooling. So what is adiabatic cooling? With the expansion of the air pocket or with the contraction of the air pocket, if temperature changes, that is your adiabatic process. It is written in your handout. Just underline that. लिखा होगा. Got it? So never ever be confused with this two lapse rate. Many of the students I have seen, they do not know whether they are same or different. They consider that is more or less same. ऐसा ही है, कुछ atmosphere ठंडा हो रहा है. Yes, they two are very different. One is about static atmosphere. Second is about the air when it is going up and coming down. What is happening to its temperature? Now, please understand this carefully. Generally, for every 1 kilometer, generally, if the air is uplifted, it will lose its temperature by 10 degrees C. ठीक है? आ जाओ. कौन है? इंटरव्यू वाले होंगे शायद, आए नहीं है ना, कोई बात नहीं. सही है. कुछ लोग तो इंटेंशनली भी नहीं आना चाहते हैं. दे विल जस्ट टेक यू टर्न कि ठीक है ना, चलते हैं, साइक्लोन चल रहा होगा, है ना. इन द मिड ऑफ साइक्लोन हु वांट्स टू कम, राइट? नाउ सी हियर इफ वी वांट टू अंडरस्टैंड, कोई आना चाहता है साइक्लोन के बीच में? नहीं ना. आई वांट टू, बिकॉज इट इज आई इज काम ना. सो ठीक है. सी हियर नाउ द कॉन्सेप्ट ऑफ स्टेबिलिटी and instability or instability. Now, what is stability? What is instability? I am talking about in terms of atmospheric stability, okay? Now, see here, atmospheric stability, what do you understand by that? It means there is no rainfall, okay? Or we can also say this is anticyclonic condition. Please remember that. Anticyclonic situation. The instability means it is cyclonic condition, okay? Now see here, the three conditions I am just showing you in diagram way. It is also given in your diagram as well. See here now. Yes. Now see here. See here now. These diagrams also are given in your handout. Please understand on the board, there is nothing. Very simple they are. See here now. For example, if I say this side, it is ELR. What is ELR? The atmospheric layers and how much they are cooler and warmer. See here. This is, I am assuming here, what is ELR? At 1 kilometer, temperature has decreased how much? 12. This is again 12. Sir, but you said 6.5 average hai. That is averaged out. Generally, average on an average 6.5, but it can vary. Sometime it will be less than 6. Sometime it can be more than 6. समझ में आया? So right now, if I assume that this is 12 degrees C with every 1 kilometer, the atmosphere is becoming cooler. See here, this case. In this case, always you will see the air will expand, and after 1 kilometer, temperature will drop around 10 degrees C. So see here, I am assuming the same was the temperature, 40. Okay. It reached to 1000 meter, 28. Here, this is 30. Tell me which is warmer. Which is warmer? This one, air pocket is warmer compared to the atmosphere. If it is warmer than the atmosphere, where it should go? Up or down? It is going in upward direction. Why? Because it is warmer, it is lighter. समझ में आया? It is going further up. Now, when it is going further up, its temperature has decreased to how much? Again by 10, 20. This is here, temperature is 16. Is it warmer? Yes, it is still warmer. Now, what happened is, it has also released its latent heat of condensation. If the latent heat of condensation has been released, now tell me what will happen to the surrounding atmosphere. Will it become slightly warmer? Yes or no? Yes. Now surrounding has become slightly warmer. And now because surrounding is becoming slightly warmer, will this same rate will be maintained now? Answer is no. It will cool now slightly lesser with the rate. So rate will reduce and diminish. Can you see this? After 20, it is 6. Why? Because now the atmosphere has become slightly warmer because of release of what? Latent heat of condensation. समझ में आया? And that is how you can see this is the adiabatic rate. Now I will show you some cases. See here now. One case when ELR is lesser than ADLR. What do you understand by that? The environmental lapse rate is lesser. See here, with every 1 kilometer, see here, this temperature is only 5 degrees C is changing. Can you see that? 5 degrees C is the ELR. Whereas I am assuming ADLR is greater. ADLR again 10, 10, and then what will happen? 6 around, and then 6 around, and then 6 around. Why? Because of moisture has been released, or we can say because of latent release of the condensation energy. Yes or no? Yes. Now see here. If I compare, see here, if I compare at this elevation, temperature nearby 35, nearby air is warmer than the air uplifted. This is colder, na? What should happen then? If it is colder, will it rise automatically? Answer is no. Yes or no? Yes. It will not rise. Now see here, after reaching to this stage, see here, the temperature is still how much? 20. Is it colder than the surrounding? Yes. Will it rise? Answer is no. After reaching to every that elevation, this is 14, 25, which is warmer. Atmosphere is warmer at every elevation compared to the air pocket which has been uplifted, and therefore what will happen? The stable conditions would remain. Stable means the air pocket is not rising. Sir, but here you have shown, ये मैं दिखा रहा हूं कि if this is rising, what will happen with every elevation? समझ में आया? So if the ADL, that is adiabatic lapse rate, is greater than the environmental lapse rate, it will always promote what? Stability of the atmospheric conditions. समझ में आया? Yes or no? Tell me if this is no. Everyone? Just you have to set up the temperatures here and just see here which is warmer. The warmer one will rise. बस इतना समझना है. If the air pocket is warmer than surrounding, it will go up. If it is not, then it will remain stable. ठीक है? So at every elevation, it is stable. That is the reason we will say that is stable. हाँ वही तो. It is not rising. Yes. Therefore, it is stable. Now, if I reverse that formula, what will happen then? At every elevation, this will become warmer. Now, let's see that condition. समझ में आ रहा है? Now, see here, second case. Just we have flipped that. Now, see here, 16 degree, 20 degree. Is it warmer? Yes, it will go up. 4 degree C. This is 14 degree C. Warmer? This will go up. And if the air is rising automatically because the warmer it is compared to the surrounding, then it will finally reach to what? It will finally reach to the condensation stage and the rainfall will occur. What is this condition? Instability. समझ में आया? Yes or no? Now the third condition, where some condition is there. If the condition is breached, then it will go towards instability. See here now. For example, this is conditional instability. Now see here, temperature is changing 8 degrees C ना यहाँ पे देखो 8 degree C. Okay, ELR is 8 degree C. Now here if you will see, in the lower portion it is 10, but after then what will happen? The rate will become slower. The rate is around how much? 6. Now if you compare in this case, see here 40, 40, now here 30, 32. Is it colder? It is colder. But if something happens, what is that something? Some force is pushing this air to go up. For example, force is coming from the ground, let's say strong convection. Then what will happen? It will be forcefully uplifted. If it is uplifted, the temperature is now how much? 20. Then still this force is deriving. The force is required. So with some force, what will happen? It may still be deflected up. And if there is no force, what will happen? It will remain there only. And that is your conditional stability and instability. If the conditions are breached by some external force, that is the convection or something, and the air is made to go up, then what will happen? It will cause again instability. So these conditions are known as conditional stability, conditional instability. बस इतना आपको समझना है for the prelims. Now tell me, is it clear? The only principle that you will keep in mind, if the surrounding air is colder and the air which has been uplifted is warmer, then automatically it will go up. And it will cause what? It will cause the instability. Just these 3 diagrams and this concept is over. समझ में आया? This is, however, not being asked generally. It is the optional wala area, but still I have discussed in the rare case, if it is asked, this is the answer. Done? Now we are... हाँ वही तो है, पूरा डिस्कशन यही तो है. No, 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 this one. This will always up to here 10. It will remain 10. Once if the latent heat is released, it will reduce to 6.5. So this will return 6.5. Okay? Yes or no? Yes. All these conditions and everything is given in your handout. Everything is mentioned there. Yes? Now see here, please understand here carefully. When the temperature, if it is going up, will reduce by 10 degrees C, it is known as adiabatic lapse rate. Which one? Dry. Because the dry it is. After this saturation energy, this latent heat of energy is coming out, then this rate will reduce, and this is known as wet adiabatic lapse rate. So dry is 10, wet would be around 6.5. They are mentioned in your handout. Just see that. Wet or the moist adiabatic lapse rate. Got it? Have you found that? Wet and moist or the dry? After this diagrams, I think probably it would be mentioned. In the definition wise, it is mentioned. आपका handout दिखाओ. Just give me your handout. Just give me. See here. On the first page only here. See here. On the first page itself. Dry adiabatic lapse rate 10 degrees C. And moist 6.5. It is considered 6.5, 6 degree or 6.5, sometime 5.5 also. Okay? It is your moist adiabatic lapse rate. Now see here. If the air is coming down, its temperature will increase by 10 degrees C, and that will be known as dry adiabatic lapse rate. Okay? So air, when it is sinking down, there is no concept of latent heat of condensation, release or something. So always its temperature is going to increase by how much? 10%. But when it is rising, its temperature will come down 10 initially. When after the latent heat of, let's say, condensation is released, the temperature will decrease now by some lesser rate. That is known as moist or the wet adiabatic lapse rate. Got it? Yes? This is only for your prelims. Only this much is required. Next, I am moving to rainfall types. Okay? The types of rainfall. Types of rainfall now. Three type of rainfalls are possible. Number one, convectional. हाँ जी, क्या पूछना बताओ. Yes, tell me. क्यों आया है वो डिफरेंस? Why there is difference here? Why this temperature is reducing 40 to 30? क्यों हुआ? हाँ तो 10 डिग्री सी कम हुआ तभी आपका यहाँ पे कंपैरिजन कर रहे हैं ना हम. You are saying what is the use of this rate? If there is no rate, then how you will compare these temperatures in the upper atmosphere? कैसे करोगे? 30 आया कहाँ से यहाँ पे? If the air is rising तभी आया ना. तो फिर आप कह रहे हो ये क्यों यूज किया? तो कैसे 30 कहाँ से आएगा ये? If the air, according to you, if the air is moving and if the temperature is dropping, it is not at all important. आप सिर्फ देख रहे हो यहाँ पे एयर का टेम्परेचर क्या है. Then you are looking at normal this one, ELR only. The air pocket specifically, when we are talking about how much of the drop is registered by that volume of air, then it is adiabatic. यही तो समझा रहा हूं मैं तब से. नहीं होगा ना, आपके हिसाब से क्यों होगा? This is usual. I am telling you, this is what I am teaching you. It is factual. It is established. ठीक है? So this is established. 10 degree से ही होगा on an average. Right? Now other variations if they are there, तो ठीक है, वो variation माने जाएंगे, anomalies मानी जाएंगी. On an average, this would be the rate. This has been established. ठीक है? Now see. हाँ जी. हाँ. हाँ, yes, yes. Yes. So then I said that thing now only. That is where? Because it is in the initial, the moisture is not converting into the water droplet. The release of heat is not there. Yes. When it is going towards saturation, then its rate will diminish. And उसको हम बोलते हैं moist. ठीक है? Done? Hello? Yes? Rainfall now? Yes. Some temperature will be dropped now with the rainfall. Yes. Now say here. I have the luxury. I can drop so many things. ठीक है? In the name of rapid revision. बोल सकता हूँ ना मैं? In the rapid revision. But I want you to learn each and everything which is important for the prelims. And I can assure you, you will have all the questions almost in the prelims related to our class only. ठीक है? Most of the questions you will be able to solve if you know how to apply this logics and let's say tricks which you have learned here. ठीक है? Because sometimes it requires application of knowledge also. And फिर आप कहोगे कि सर ने ये तो बताया था but यहाँ पे ये चीज डाल दी तो क्या करें? तो सर तो आएंगे नहीं वहां पे. If some new thing has been inserted, it is your application of knowledge will matter then. ठीक है? See here now. Yes, see here now. The rainfall we were talking about. Rainfall, convectional. Second is that is orographic, and the third one is known as the frontal or the cyclonic. Or cyclonic. See here, convectional, orographic, frontal or cyclonic. See here, the first one, convectional means it is because of the thermal heating of the surface. That will be because of thermal heating of the surface. And because of that thermal heating, the air will rise, and that rising air will cool down. It will give rise to what? The formation of the clouds, and finally rainfall is going to occur. This is convectional rainfall. So thermal heating of the surface is causing this upliftment. In the second case, the warm air is rising because of what? The orographic or the mountain barrier. Mountain barrier. So here it is the mountain barrier. And the rainfall will occur mostly in which side? The wind from where they are coming, the rainfall will occur that side. Frontal, it is because of the formation of fronts or with cyclones. With cyclones. So this is shown in the diagrammatic way in this way. For example, the warm air is rising up while interacting with the cold air in case of fronts, and in the tropical cyclone in general also. One by one we will discuss. First is convectional rainfall. See here now. Convectional rainfall, the first one. See here now. Done. Convectional rainfall. Now convectional rainfall, essentially it is a summer phenomena. Okay, summer means we need the thermal hot surfaces, right? Now see here, convectional rainfall means the thermal heating of the surface is required. Number one, thermal heating is required of surfaces is required. Number one. And because of that, which season is most preferred? The summer season would be the most preferred one for this type of rainfall to occur. Okay, number one. Number two, in especially equatorial region, because equator is known for what? Equatorial region are known for throughout high temperature throughout the year. Throughout year, high temperatures are there in the equator. It is often said because of entire year the temperatures remain very high. It is also said that equator is known for absence of seasons. Okay, there is no season except summer in the equator, and the only winter that you want to experience, that would be their night. In the night, temperature will drop 5 to 7 degree, and that is the winter for that area. Otherwise there is no season, right? So remember that one. Because of high temperature throughout the year, equator is known for what? Absence of seasons. Those people who are living there now, they are so adapted to high temperature. Even 5 degrees C drop in the night, that will cause real time winter for them. because they are adapted to high temperatures, right? Therefore, it is said the only winter that you want to enjoy in the equatorial type of climate is night. Okay. Now see here, equatorial type of the climate is known for this heating throughout the year, and therefore this is a daily phenomena, daily basis rainfall phenomena in equatorial region. Phenomenon in equatorial region, and this is around 4 p.m. in the evening that happens, and because of that what happens is it is also known as 4 o'clock rainfall in that area. Okay, it is on daily basis rainfall occurs at around 4 p.m. Now see here, why 4 p.m.? See here, maximum insolation which time? 12 p.m. maximum insolation, maximum temperature 2 p.m. and after this 2 p.m. it will take some time for what? For the convection to occur and the cloud to form, and this will be the time after some 2 p.m. it is 4 p.m. and here the rainfall will start, and that is your 4 o'clock rainfall. That is a daily basis phenomena in equatorial type of climate. This rainfall is very high. It will be more than 150 centimeter. Generally it is 200 plus, so I'm writing 200 centimeter plus rainfall will be registered in the equatorial region on an average throughout the year, right? Now see here, because of this high rainfall, you will see equatorial areas are known for what? They are known for the rich luxurious forests. So this forest will have multiple layers. See here, this is the layers, the multiple layers, and in this 4 to 5 layers of vegetation, this is 4 to 5 layers of vegetations are found, of vegetation, and rich forests are found. That is evergreen equatorial type of rainforest. Because of this high amount of rainfall, we have this kind of vegetation and the forest in the equatorial region. Also you will have this kind of vegetation. Kya bolte hain inko? Yes, it is epiphyte, right? So you will not only have this 4 to 5 layers, also the epiphytes are found in this kind of atmospheric condition or the equatorial type of climatic condition. Now see here, because of this high rainfall, now what happens is, because of high rainfall, whatever the rainfall is here now, because of high rainfall, see here, you will see the soil will go through what? Soil will go through intense leaching and erosion. So soil erosion is a very common phenomena, and leaching of nutrients will occur. What is the meaning of nutrients leaching? They will be washed away by the rainfall, except some nutrient. What are these nutrients? Some nutrients like aluminium and ferrous, they will be left with the soil, and this kind of soil lacking all the other minerals except aluminium and ferrous, this is known as laterite soil. Okay, so this is known as laterite soil. Laterite soil. This soil, because of the presence of ferrous, however, this is in literal meaning, laterite soil means brick making soil. You can make bricks out of that because it is not useful much for the agriculture. However, if I use the synthetic fertilizers, then I can use this soil for plantation especially. Why? Because coffee loves this iron part. So coffee plantation and tea plantation is something that we can grow. So if I add here, see here, if I add here laterite soil with application of synthetic fertilizers, this can be used in the plantation purpose. This soil can be used in the plantation purpose. Especially which plantation? Coffee. Okay, coffee. Now see here, if I show you this kind of soil, I'm not talking about this kind of rainfall, only soil I'm talking about. Let's say this is the Western Ghat area. Also, this side of the Western Ghat, you will have very high rainfall, yes or no? I'm not talking about convectional rainfall. Which kind of rainfall it is? It is, however, orographic in nature, but the rainfall is very fast. And because of this rainfall here also, what kind of soil is found? In this area also, you will have which soil it is? Laterite soil. Now, are you aware about this? The Karnataka, especially Baba Bhudan Hills, are famous for which type of plantation? Coffee. Then Kerala, and this Kerala is also famous for what? Coffee, tea, then some rubber. This type of plantation is also there in the Kerala. Why? Can you understand that? Because of the presence of what? Laterite soil. So this is also we have the laterite soil in this area. That is Kerala, Karnataka, in fact Goa also. Goa, what is famous in Goa? Cashew plantation. Here Karnataka, coffee, Baba Budan Hills. Baba Budan Hills. Yes, and here in the Kerala we have the plantation of coffee, tea. With rubber. Yes. So this soil can be best utilized in the plantation. With this, we also have learned about the equatorial type of climate. Now say here, equatorial type of climate throughout the year, high temperature. Which kind of forests are there? Evergreen, 4 to 5 layers. Why these layers are there? Why this rich forests are there? Because of very high amount of rainfall. Yes or no? Yes. In the equatorial region, if once I clear these forests, can you grow them again? Why? Because number one, now the soil no more has the nutrients, as well as it lacks organic content as well. Can you tell me why organic content is not there? because of the runoff, number one. Number two, because of the high temperature and moisture, bacterial activity is also very faster. So bacteria will decompose rest of the organic matter if it is left. समझ में आया? So please remember, equatorial forests, if once are cleared, they cannot be grown again, because the soil which is found right now in the equatorial region, it lacks both minerals plus humus content or the organic content. Why the organic content is not there? I'm just writing here. Why the organic content is not there? Because of organic content, because of faster bacterial decomposition. Plus runoff of water. Runoff means the floods like runoff. Okay? The floods are going on. Therefore, the organic content is also removed. कब रखे गए यार? कब आए थे? बताया क्यों नहीं आप लोगों ने? ठीक है. So this is all about the rainfall, that is your convectional rainfall. Now if I ask you some questions, ठीक है? Without looking at document, just look at here. Just tell me, this type of rainfall only is the phenomena of lower latitudes. This kind of rainfall is the only phenomena of the lower latitudes. Convectional rainfall. Only it is found in lower latitude. No? This kind of rainfall can only happen in the summers. अरे अभी तो बोला समर, अभी तो लिखा है. You are saying no. ऐसे मत करो. Yes, it is summer phenomena. Yes. Tell me, which kind of clouds will be formed if the air is rising faster? Which type of... Now please understand this one more logic. If the air is rising simple and gentle in way, the clouds will form stratus, sheet-like. If the air is rising vertically, then it will lead to what? Vertical clouds. Vertical cloud means cumulonimbus. In equatorial type of rainfall, which type of clouds are going to form? Cumulonimbus. Okay? Please remember. Now, please, one more thing. Please understand this carefully. Cumulonimbus clouds, I will explain in the thunderstorm shortly. Cumulonimbus clouds are associated with heavy rainfall, but of short duration. Okay? Yes or no? Yes. Then second, cumulonimbus clouds can be associated with lightning, thunder and hailstorm as well. Yes, it is. I am using the word can be. Yes, not every time hailstorms would be there, but most often that would be there. Okay? So now my question is, this convectional type of rainfall can occur only in lower latitudes. Yes or no? No or yes? Convection type of rainfall can only occur in lower latitudes. Yes or no? No or yes? Not true? Not true? Yes or no? Second statement. ठीक है, इसके बारे में सोचिए. Second statement. The convectional type of rainfall can also occur in hot deserts. No? Now write some notes. Number one. Number one, convectional rainfall is common. It is in your handout, I think. It is in your handout. Just see some notes I am mentioning. है कि नहीं है देखो. Convectional rainfall, just give me your handout. Just I want to see this 3-4 notes I just want to give you. Where it is given? Is it given? Yes. Yes. Come to second para, point number A and B. Just above the diagram. These are the notes. Please mark them important. Temperate region also can go through this kind of rainfall, as well as it is found in the hot deserts. Now tell me, if there is a desert, is there any mountain in the deserts? Generally no. Then how come sometime rainfall will occur there? What could be the method? क्या हो सकता है? It is only the convection, yes or no? Yes. Please remember, convectional rainfall is possible. Convectional means very hot is the surface, and all of a sudden, if the air is rising, somewhere from moisture is there in the air. Moisture can come from nearby regions, lakes or something. Yes or no? If there is playa lake or something in the deserts, oasis होते हैं. For example, nearby this oasis, the warm and moist air is there. It can be uplifted, can cause rainfall. Yes. This moisture can also be added by western disturbances. Yes or no? Over Rajasthan as well. Yes. So please remember, convectional rainfall can occur in lower latitudes very commonly, but it is also found in temperate regions as well. But condition apply only in summers. And now the two things here. In case of, say here, notes are written now. Hot deserts, it is not regular, irregular and sudden. Yes, that is true. One more thing that you will remember, it is also mentioned in your note. Cumulo, no, it is not mentioned. Just let me see. No, one note. What is this note? Now say here, the one note, if I compare the equatorial region and the temperate region, where the rainfall will occur faster. Equatorial region, where the rainfall will occur gently. Temperate region, where the rainfall will occur for greater duration, greater amount in the temperate region. Now see here, we have the same cloud. Let's say this is the same cloud. It is having the 1000 ml of the moisture. If I suddenly compress, this is, see here, if I suddenly compress, see here, if suddenly compress, this will cause the rainfall to occur. Instead of that, I am just slowly and gradually, I am just cooling that. So slowly this water will come out. That is how the horizontal cooling will occur. And which type of clouds? They are, even if they are, which type of clouds? Even if they are this kind, cumulonimbus cloud in temperate region, because of comparatively less powerful vertical upliftment, they will give you more amount of rainfall in terms of time duration. समझ में आया? So just one note you can fix in there. Write down. Note number 1. This rainfall also found in temperate regions. This rainfall is also found in temperate regions. Also found in temperate regions. Also found in temperate regions. And compared to tropical regions or compared to lower latitudes, compared to lower latitudes, rainfall will be slower but of long duration. But of long duration. Of long duration. Rest of the notes already are mentioned, A and B point. That is, what is the A and B? That rainfall can occur even in hot deserts also, but it will be highly irregular and sudden. Yes. Do you remember that shattering, weathering, physical weathering, shattering? In that shattering, the hot rock was there in the desert. All of a sudden, there was rainfall. What this rainfall is? Sudden rainfall is caused by this convections. Okay. So first type of rainfall is over. Second type, orographic rainfall now. Equatorial type of climate also we have understood, right? Now see here, second one. Orographic rainfall. Orographic rainfall. So what will happen in this kind of rainfall? See here. The first thing that is in the notes I'm writing here, number 1, first note is most rainfall occurring across the world. Most rainfall occurring across the world, it is caused by what? It is caused by orographic factor. Number one, this is important. Most of the rainfall occurring across the world, it is caused by orographic factor. Now see here, this is mountain. Now see here, the one side that is warm and moist air, it is being uplifted. So warm and moist air, when it is reaching up to here, it will cause the rainfall to occur. See here, the rainfall will occur. This rainfall will be limited to which side? This is going to be windward side, from where the winds are coming. Rainfall will be here. The other side, what will happen? You will have warmer air, and this warmer air will not cause much of the precipitation. Why? This side is known as rain shadow region. It is not going to cause much of the rainfall. Okay, because of number one, lack of moisture with the air. Why? Because moisture was used in the precipitation in the other side. And second, increasing temperature of the air. What will happen if the temperature is increasing? Yes, increasing temperature of air, which will result in higher humidity capacity. If the humidity capacity is increased, what will happen? Air will not shade its moisture easily. So because of this two reason, you will see rain shadow regions here. And the other side of the mountain, you will see generally deserts. Which deserts? They are known as cold deserts. Hot deserts, we have learned 4-5 reasons I gave you. Yes, the cold deserts, if you will open your atlas, page number 66 and 70 respectively, please see this. Humidity capacity. Humidity capacity. Humidity capacity. Okay, humidity capacity will increase. वापस आओगे ना? वापस आओगे ना? पक्का? हाँ ठीक. Now see here, what will happen? The other side of the page number 66 and 70, if you will open, if you can locate this Gobi Desert, Taklamakan, over China, Mongolia area. Can you see this Ladakh Desert? The desert of Ladakh. Then Taklamakan. Mile? Taklamakan, Gobi Desert. Are they located in this belt of 2030? Answer is no. They are in the higher latitude. They are cold deserts. Then what is the reason? Kya hai reason? Why there is no rainfall in Ladakh? It is the rain shadow side of what? Himalayas. Himalayas other side is rain shadow region. So Ladakh desert. In the same way, this Taklamakan, they all are rain shadow region. Why? Because Himalaya is preventing the air to go in that areas. So this is the reason. Cold deserts of the world are located in this area. One more desert that you will locate. यहाँ पे locate किया आपने Gobi, Taklamakan, yes, Tian Shan. These will be the deserts. मिले? Ladakh desert, yes. Now open page number. It will be 86 and 90. 86 and 90. Not 86, it would be 88 and 92, sorry. 88 and 92. Mila, just try to see the region here beyond 40. Can you locate one desert there in the South America? What is the name of that desert? Is it Patagonia? Can you see what is the latitudes of the Patagonia? Latitude बताओ. It is दूसरी लाए आप दूसरी लाए हो पहले रख के गए थे ये. अरे यार आपका काम बढ़ा रहा हूँ मैं, इसी को गर्म कर देते हैं. Thank you. Now see here, Patagonia. What is the latitude? What is the latitude? It is more than 45. It is not located in 2030 STHP belt. It means what could be the reason behind its formation? It is rain shadow region of which mountain? If you can see, it is Andes, and Andes are very higher. So what happens is when the air comes down from the Andes, it becomes very dry. Patagonia is the driest desert in the world because of this reason. Okay? Yes. Now some of the points. Say here, what are the important areas that you should understand clearly and carefully? Number one, is it the orographic rainfall dependent on season, or it can happen in any of the season? Any of the season. And what about the convectional rainfall? Only in the summers. Which rainfall will cause most of the rainfall? Orographic rainfall. Now tell me, will the height of mountain matters? Yes, height of mountain will matter. Will the orientation of mountain matter? Yes, if they are parallel to the winds, they will be causing no much rainfall. Example, Aravalli is Rajasthan. If they are blocking the winds, Western Ghat, then they are nothing but they will cause more rainfall, right? Now see here some points one by one. See here. The one thing that you will remember, characteristics I'm talking about, which side will receive rainfall here? That is windward side. This will remain dry. Example, see here in your atlas 10 and 13, page number 10 and 13, physical. Page number 10 and 13, physical India. Just try to locate Bangalore and Mangalore. Bangalore and Mangalore. Bangalore and Mangalore. Which is this side? See here. If this is the Western Ghat, see here. This is the Western Ghat. Here, which is the side in which the Mangalore is located? This side, or Mangalore is 1 or 2? Mangalore is at one side, so it will receive more rainfall compared to the Bangalore. Why? Because in the western side. The second example, Mumbai, Nasik. Mumbai, Nasik, Mumbai, Khandala, Mumbai, Pune. They all are here. Mumbai, Nasik, Mumbai, Pune, Mumbai, Khandala. They all are here. Third example, see here. Third example. Here we have Garo Khasi Jaintia Hill. Yes. This is Mohsin Ram. And this side also we have the another, that is Cherrapunji. Yes. So are they in the this side, windward side, or in the other side? They are in the windward side. So therefore they receive a lot of rainfall compared to Gangatok. Can you locate this Gangatok? Kahan pe Gangatok? Other side of the mountain. Gangatok will receive less rainfall. Why? Because of this orography factor. So remember this one, orographic rainfall will be more in which side? Windward side. The other side will be rain shadow. Can you see here in case of India, this is Vidarbha region. This is also infamous for the farmer suicide. Because of what? Because of this is also arid area. There is no much rainfall in this region, right? So this is the orographic rainfall we are talking about. Now some more characteristics. One we have received. What is the first point? The windward side will receive more rainfall. Examples, be careful. These examples are important, right? Some more areas if I want to tell you, see here, some more areas. Can you locate Kochi here? Kochi किस side है? Kochi, western side. What is the city which is near to Kochi but in the other side? Just ये काम करना है आपको. Number one. Number two, huh? Can you see that? The other city, that side you will see. The one side, western side you will see. The second side here you will see. If you will see here, one side you have Mahabaleshwar. Second side you have Panchgani Plateau. Can you locate this? I'm giving you some homework. If this is not visible here, the Mahabaleshwar, the homework for you. Mahabaleshwar, near Maharashtra, or Panchgani Plateau. Which one will receive more rainfall? Panchgani. Which one is going to receive more rainfall? Mahabaleshwar? Yes or no? Have you found that? Yes, good. This is your homework. Which one is going to receive more rainfall? It is Mahabaleshwar, right? Panchgani will be in the other side. In the same way, what is your homework? Please say here. What is your homework? You will try to locate some important cities here. For example, if it is Kochi here, what is the city just nearby? Big city nearby Kochi. तो आपको ये देखना है. Madurai? है? Yes. Now come to the next side. This is the one feature. That is the windward side will receive more rainfall. Second feature now. Second feature. Second characteristic. It can occur in any of the season. Any season. Any part of the world, any time of the day, anywhere it can occur. It is not similar to convection in that way also. Third, see here, third. Third, if I am going, let's say, mountain height, see here. If I ask you for the good rainfall to occur, the continental mountains located away from the coast and second side coastal mountain, for good rainfall to occur, which must be higher? Which must be more higher in terms of height? Continental, which are in the deep interior, whereas coastal mountains, even if they are smaller, they can cause good rainfall. So please remember this one. Why it is so? Anyone? Because amount of moisture would be more in this nearby. See here, this is the Western Ghats. See here, in this area, if we talk about our air pocket, this is loaded with, let's say here, 800 ml of the moisture. This is total capacity 1000. How much you will uplift? Only after uplifting a small height, it will reach to what? Saturation? Yes. But when it comes to Himalaya, see here, when it is causing rainfall in this entire area, and when it reaches to Himalaya, it will be left with 100 ml of the moisture. What is the capacity? 800. So how much of the upliftment is required for the good rainfall to occur? Huge heights must be there. Yes. So please remember, for the good rainfall to occur, continental mountains must be of greater height. Of greater height. And smaller mountains parallel to the coast. The coast can cause good rainfall. Good rainfall. Okay. Smaller mountains parallel to the coast can cause good rainfall. Example, Western Ghats. Example, Western Ghat. This is not true always. Please remember, Eastern Ghat ke case mein it is not true. Why? Because winds are not entering from this way. Winds are entering from this side. Not always true, but yes, it is usually true. The condition apply is wind should come. Okay. Next. Now tell me, the height we have seen. Is this orientation is important of the mountain? Yes or no? Yes, orientation is also important. Orientation is also important. Example, see here, this is the Western Ghats. They are blocking the winds effectively, whereas Aravalli, the winds will pass in parallel manner. Blocking the winds effectively. Okay, the winds will pass parallel. Therefore, no much rainfall here. Most of the rainfall will occur here. Orientation does matter. Okay, Hanji. नहीं होता ना, Bay of Bengal branch will go in this way na. So why the air will not come from here? The winds will not come from here. This is rather passing that way. Okay. Next, now we have seen how many points? 4. Fifth point now. See here. Fifth point. Now, this is the reason. See here. If I am going with the height, what will happen to the rainfall in orographic rainfall? The rainfall will increase with height or it should decrease? It will increase with the height. As I'm going up in the altitude wise, rainfall will increase. समझ में आया क्यों? Because more condensation, more rainfall will occur. With altitude, rainfall is bound to increase. Are these written in your handout also? Yes. One last point I'm making here. See here. If this is the same mountain, let's say Himalaya. Himalaya. And if I locate the Shimla, Nainital, everything is here. Delhi is slightly away. Okay. So see here. Tell me, if I am going away from the foothills of mountain, what will happen to the rainfall? Rainfall will decrease. Yes or no? Yes. Similarly, rainfall will decrease. So please remember, if I am going away from the foothills, these are the foothills of the Himalaya. If I am going away from the foothills, the rainfall is going to decrease. So rainfall will decrease. Yes. So these all are the characteristic feature. And one feature that you will remember, this type of rainfall can occur any of the season, any of the part of the world, and most of the rainfall is going to occur by this type of rainfall. Samajh mein aaya? So that is the rainfall. The third one now we are left with, it must have been given in terms of from rainfall decreases. It is already mentioned in your document, right? So still I'm writing. Rainfall decreases with distance from foothills. From foothills. With the distance from foothills. Okay. That is over. Okay. Next is the last one, that is the frontal or the cyclonic. Now, in order to understand this rainfall, first we have to understand the fronts and cyclone. Then you will understand what kind of rainfall it is going to be. So now, in order to understand this rainfall, we need the dimensions of fronts and cyclone. If we want to understand the fronts, first we need the understanding of air masses, and then we will enter into the fronts. So the next topic before going into this third kind of rainfall, that is air masses and fronts. Okay, so give the heading air masses and fronts. Air masses. Maharashtra mein. One side, yes. Okay. Now see here. The next topic that is we are starting, that is air masses and fronts. What is an air mass? Tell me. By definition, tell me. What is an air mass? It is, yes, give me the definition. It is the large column of air when it comes to horizontal expansion. Okay? It is the large column of air. In terms of horizontal expansion, it can be thousands of kilometers. Okay? Thousands of kilometers. With having the similar properties. What properties? 3 properties are generally required. If they are mentioned, please underline in your document. Number one, the amount of water vapor or the moisture. Is it written? Then temperature and then lapse rate. Lapse rate means, now see here, what is the lapse rate? How the temperature is decreasing or increasing, right? So lapse rate, now see here. This is the surface. Let's say this is the surface. Now in this superficial area, over this surface, let's say there is one warm air mass. I'm considering this is the warm air mass. This is the air mass. And in terms of its vertical height, how much it can grow vertically? Can you tell me? How much it is the maximum possibility can exist vertically height of the air column? Kahan tak ho sakta hai? Maximum how much? Can I say this is the tropopause maximum? So this would be up to 14, 15, 16 kilometer. So up to tropopause it can go. Troposphere is the length in which it can go. Now see here, this can be in terms of horizontal expansion, thousands of kilometers. Now see here, what are the properties? They must be same. Temperature, number one, more or less it should be same. Second is amount of moisture that it has. And the third is when you are going up, the temperature is reducing in the same way. That is with every 1 kilometer, if it is 6.5, then next 1 kilometer also the temperature should reduce how much? 6.5. These are the key characteristic feature of an air mass. Samajh mein aaya? Yes. Now see here how the air masses are formed and what are the characteristics. So see here. Characteristics. Now these characteristics, see here, the area on which the air masses are going to form, these areas are known as source regions. Okay, these are known as source regions. The areas over which the air masses are going to rise, they are known as source region. Now see here. The conditions for the formation. Now see here, if I ask you, let's say this is the mountain and here let's say we have the ocean. This is the mountain. Here we have the ocean. See here. If there is one air mass which is now in this way, this is one. Second is this one. Third is this one. Fourth is this one. Fifth is this one. Tell me how many out of them qualified to be called as an air mass? How many of them are qualified? 1 and 5. What happens to 2? What will happen to 2? Why? Because of half part is over the ocean, amount of moisture will be more, and half part is over the land, moisture will be, temperature will be different, half of the part, temperature will be different, half of the part. This one, altitude here, temperature would be different. If you are going further up, temperature will decrease, temperature conditions will be different, temperature conditions will be different. Fourth, same way, it is going to be different temperatures. Fifth, it is entirely over what? Entirely over ocean. And therefore, it can have the more or less same homogeneous properties, right? So what are the conditions which are required to form an air mass? Please remember these conditions. Number 1, or conditions or favorable factors. Favorable factors. Now, what are these favorable factors? Favorable factor. Now, see here. Number one, we need large homogeneous. What do you understand by homogeneous? If it is land, then it must remain land throughout the region. Homogeneous surfaces, either land or oceans. Okay, number one. Number two, now tell me, if there is an air mass which was developing over the surface and this air mass was going through, say here, what happened in this air mass? See here, in this air mass, because of the upliftment from here, what happened is, because of the upliftment, now see here, convection started. If the convection started, what will happen to this stable air mass? If there is convection which is starting, what will happen to this air mass? Will it be dispersed? Yes or no? Yes. Will it cease to exist? Yes or no? Yes. Because of the convection, the entire air mass can be disrupted. And therefore, what is required? You need convection or you need atmospheric stability. We need anticyclonic condition or cyclonic condition. Anticyclonic condition. Second, we need anticyclonic conditions or atmospheric stable conditions. Atmospheric stable conditions, and convergence should not be there. Okay, please remember that. Convergence should not be there. Number two. Number three, see here. Can I say it will also depend on time spent by an air mass? Yes or no? Time spent, if it is good amount of time or of time spent over source region. Right? So that will also determine the air mass and its homogeneousness. Okay, homogeneous would be the conditions in terms of air mass properties. Now tell me how these conditions can be changed. Let's say the properties which air mass has, how they can be changed. If I give you some options, tell me. The characteristics or the properties of the air mass will depend on which of the following factor. Number one, the amount it has spent over the source region. Yes. Second, the travel or the journey which it has completed from one region to another. Will it introduce the change? Yes. Tell me the atmospheric and weather conditions in nearby. Yes or no? Yes. So, and fourth, the source region over which it is developing and traveling. Yes or no? Yes. So these all are the factors. I think they all are given in your handout. Just dekho. Each and every factor is given in your handout. Just see that. Are they given? All the factors are given. All the things are given. Classification, is it given? Classification of an air mass, I think it is not added. Let me see your handout. Classification, is it mentioned? Classification is not there. Hanji. If there is divergence of air, it is going to be favorable condition. Divergence means air is sinking and here the stability is there. So air will sink in this way. Okay? It will create stability. Stability means there is no rainfall. There is no rising air. So if the air is sinking, it will pile up here near the ground and that will cause this air mass to rise. Okay? That is the best condition required for the any air mass to form. Now write down type of air masses. Write down this classification if it is not there in your handout. Types. The one is I am dividing them based on where they are originating. Let's say tropical, polar. Then this is, we will use the word T. We will use the word P. It can be divided again into two: continental, maritime. We will use the word C and we will use the word M. Here also same, continental and maritime. So it will become CP and this will become MP. This will become CT and this will become MT. Then further classification, see here. Then it will be divided into see here, cold and warm. So this is warm, the cold, the same way, warm and cold and cold. So see here, the words that we are going to use for the warm, we will use small w. For cold, we will use k. Why? Because C already we have used for the continental, right? So we will use k, the w, then k in the same way. It will be divided w, it will be divided into k. This will also be divided into w and k. Then again, one more classification, that is stable and unstable. Unstable. So we will use word s, we will use word u. The same way, u and s. Words are u and s. Same way, u and s. U and s. U and s. Now, for example, I want to write the name of this air mass. See here, directly I want to write the air mass, this one, CPWU. So what it is? CPWU. In that way, I need all 16 names in your register, in your notebook. Likh loge? Yes or no? For example, if I want to write about this, it is SKMP. So what I will use this name? MPKS. Can you understand that? Yes. So 16 are the types. Okay. 16 are the types of the air masses. Now, out of the 16, can you tell me what air mass represents the southwest monsoon of India? Just think about southwest monsoon, where it is originating. Over ocean, marine it is. Is it tropical? Yes. Is it warm? Warm, yes. Unstable, yes. So what it is? MTWU, unstable, because it is causing rainfall. So MTWU kahan hai aapka? See here, this is MT, this is W, this is U. So what is this MTWU? MTWU. This is India's which monsoon? Southwest monsoon. In the same way, can you tell me northeast trade winds? Kaun sa hai? Northeast trade winds. Continental. Tropical, yes. Yes. CT. Is it cold? Yes, they are cold. Winter, October month it is. Cold winds are they? Yes. Are they stable or unstable? They are largely stable. So CTKS is nothing but which air mass? Which is your northeast trade winds. Are you able to understand? See here. The southwest monsoon. See here. It is originating here. So this is tropical or maritime? Maritime. Is it warm? Yes, it is warm. It is tropical region? Yes. Is it unstable? Yes. Therefore, it is causing rainfall. So what is it? M, T, W and U. M, T, W and U. Now see here. The second one. That is here. C. That is continental it is. Yes. It is cold. Yes. CK. Or instead of that, C first is tropical. It is in the tropics only. It is cold and it is stable or unstable. It is stable, not causes rainfall in this most of the area. So CTKS represents your which air mass? Northeast trade winds air mass. Done. Now one diagram is given in your this let's say book, that is in your handout. See this diagram, and see 6 regions are there. Is this mentioned? Which are the areas in which the air masses are going to originate? Can you see the 6 areas? First, it is your polar Arctic region where the ice is there. Right? It is in your diagram will be represented by 1. Can you see that and locate that in your diagram? 1. Second would be 1 dash. Third would be 2 dash. Third will be 3 dash. आपके इसमें दिया हुआ है. Just try to see the 6 areas. Now see here in this 6 areas. See here. Now tell me how the air masses are warm or the cold. It is decided. Can you tell me that? Whether this is warm or the cold, how it is decided? It depends on what? It depends on source region. If the source region is warmer, they will be called as warm. Now tell me if they are rising in the tropical area, they will be warm. If they are rising over the cold polar area, then they will be cold. Yes. So depending on the source region's temperature, the nature of warmness and the coldness will be decided. Done with the air mass? Yes. Last thing I just want to show you. Unstable and stable means if they are causing rainfall. For example, that rainfall wala MTW, when it entered in India, it causes rainfall. So it was unstable. Yes. They will be they will be suppressed. And if they will travel, for example, blizzard, at the time of blizzard, what happened to the America was going through cold storm. Why? Because they also can cause this storm formation, right? We will see that in the tornado. Now see here what I was showing you. Air masses, na? Yes, see here. What happened to this slide, huh? ये क्या हो रहा है? Now see here. Yes, this is the diagram. Must have been given to you. Yes. Now, is there any difficulty to understand this diagram? I have also given the number where they are originating. See here. 1, this is Arctic region. Second, this is the polar continental area, polar oceanic area. Yes. Third, this is tropical oceanic 2. And 2 dash is tropical continental. Okay. Third is the tropical oceanic and this tropical continental. And the one area which is not shown here, that must be your Southeast Asia and the air masses. These are the 6 regions. With this diagram, you will remember. Okay. So with this diagram, if they ask in the prelims, in which of the following areas air masses are going to be originated? Number 1, that is the thing. And the second thing that you will remember, now see here. Now, if I ask you, see here, air masses are important for the formation of front. Is it true? Air masses are required for the formation of fronts. Yes. Now tell me where the front formation is a common phenomena, in mid latitudes or in the lower latitudes? Mid latitudes. Yes. Everything in the air masses that is written, I have explained that. Just see that. Is there any point or the thing that is left? The source region we have learned, the characteristics we have learned. Yes. What is the significance, if I discuss, of the air masses? They can bring a lot of changes in weather and climate. Example we have seen, that is for India, MTW, southwest monsoon. At the same time, CTKS, the cold winds. Then this kind of visible changes can be introduced by this air masses. The one more role of the air mass that you are going to learn in the tornado formation. Shortly we will discuss thunderstorm and tornado, but before that we are going to fronts. We will discuss this fronts, then we will enter into thunderstorm and the tornado formation. Okay, so first is fronts. Fronts. See here, fronts. You are aware about this. We need, what is the front? Nothing but sloping boundaries. Sloping boundaries separating one side the different type of air mass. And the other side you will have completely different air mass. Okay. One side you have different, the second side you will have entirely different type of land mass, air mass. So this is the sloping region where the two contrasting air masses are going to converge. Okay. Now see here, the fronts are formed in which areas? Now for the front formation, 2 conditions you will remember. What is this 2 condition? 2C. What is 2C? One is contrasting air mass and second is convergence. Okay. That is convergence. Now see here. Now tell me where the fronts can be formed. See here. Equator, STHP. This is equator. here it is SPLP, and last is polar high. Tell me the first one by one. If we talk about equator, now which kind of air masses are there both sides of the equator? Tell me. You have the warm both the side, yes or no? The trade winds are coming from hot deserts, yes na, STHP belt, they are hot. Is there contrasting air mass? Answer is no. Is there convergence? Convergence is there, but what about contrast? It is not there. Second reason here, STHP, is there convergence? It is divergence, the air is rather sinking down. Third, here we have westerlies, yes, and the upper side we have the polar cold easterlies. So this is, we have the easterlies. And now tell me, can I say this is the area here in the SPLP? Is there convergence? Yes or no? Yes, air will go up, and this is the only area where both of the conditions will exist, and therefore they will be formed in which areas? They will be formed only in this area. That is in the mid latitudes where the cold polar easterlies and the westerlies are going to interact. Got it? Now see here. This is the front, basic things. The fronts are of four type. Fronts are of four type. One is known as warm front. Second is known as cold front. Third is known as stationary front. And fourth is known as occluded front. If you understood this air masses, front is easy. If you understand front, the temperate cyclone is easy. If you understand temperate cyclone and tropical cyclone, they are different. Tropical cyclone requires different understanding. तो वो easy नहीं बनेगा. ठीक है? So that is how this air mass, fronts and temperate cyclones are related together. One by one. First is warm front. Now, why this is known as warm front and who will decide this is warm front or the cold? Please remember this one. See here. See here. This is the area. In this area, if the warm air becomes aggressive, active, and invades territory of cold air mass, then it will be known as warm front. Because who is active? Warm air mass is active. Okay. In this case, now say here, we have the cold air mass here. In that area, it is now the warm air is entering and it is moving now. If the warm air is entering, the colder one, heavier and denser, will it leave the ground? Answer is no. Therefore, what will happen? The moving air has no other option but to rise. So when it will rise gently. So this is going to, how it is going to rise. So now this rising warm air. Now tell me, which type of cooling will occur? Faster or gradual? Faster cooling or the gradual cooling? Is this sudden upliftment? No, it is rising gradually. Because of this gradual rise, which kind of cooling will occur? Please remember, horizontal cooling means sheet-like clouds are going to form. So see here, because it is rising in this way, the clouds are going to form in this way. This is the cloud. What these clouds are? Can you give me the name? They are, which clouds? They are a stratus cloud, right? So now see here, if it is causing the rainfall, then we will call them nimbostratus. This is in the mid cloud, 2.5 to 6. It is known as alto, and its shape is a stratus, so it will be known as alto stratus cloud. The upper cloud, that is here, it will be known as cirrostratus. This is cirrostratus cloud. Okay. So what is the method in which the air is rising? The method is horizontally and gradually the air is rising. Whenever the air will rise gradually, horizontally, it will cause which type of rainfall and which kind of cloud to form? A stratus type of cloud. That is, please remember this. Gradual rise of air will cause gradual, horizontal, and sheet-like cooling. Sheet-like cooling, okay? And therefore, what happens is you will have which kind of rainfall? Please remember, cumulonimbus type of clouds will give you very heavy but short duration rainfall, whereas this kind of cloud will give you moderate, gentle, drizzling, but of longer duration. So please remember what kind of rainfall would be there. Rainfall will be drizzling, means fuhar in Hindi, right? Very fine drops. Then gentle to moderate, but comparatively of which duration? They are of longer duration. Longer duration. Okay. So this is how you will identify whether this is warm front or not. You can see the slope also. This slope is gentle. It is not vertical. Okay. So that is all about the warm front. So how it is decided? Warm is active. Warm is rising gently. The warm is rising gently. Therefore, sheet-like cooling is occurring. Sheet-like cooling will cause which kind of cloud formation? Stratus type of clouds. That is all about warm front. Yes. Yes, so summer I said na. In the temperate region, yes, summer can be there na. Himachal Pradesh वगैरह. Gradual comparatively hoga, but it would be more or less this kind of vertical one only. See here, the two kind of upliftment are possible. See here, the surface, if it is very, very hot, the air will rise in this way. If the surface is hot, but not that much, so what will happen? This kind of rainfall will occur. They both are vertical. So slightly this is gentle. Therefore, even if the cloud is forming here, that is cumulonimbus, but it will sustain longer. Because it is simply because of this type of cooling. It is not that related. See here in the fronts, this kind of cooling is going on. That is horizontal. No, it's not vertical. It is horizontal at some slope. In that case, in the previous case, whenever there is the convection would be very stronger. The air will rise more or less vertically. More vertical in the lower latitude. Less vertical, slightly slopey in the temperate regions. Okay? Next now, see here. Cold front now. Cold front. Now tell me what would be the definition of cold front? Who will become active now? Cold one. Okay, everything is written in your handout. Just see here now. Now see here. The cold one is becoming active. And who was already sitting here? The warm one was already sitting. So this is warm air mass. The cold air is now entering here, right? The cold one, that is cold air mass, if it is entering, because it is heavier and denser, what will happen? It will try to occupy the bottom. Now, who was resting there in the bottom? Kaun tha pehle se? Warm air mass. So what happens is, because it is heavier and denser, it will uproot this warm air. The warm air, if it is uprooted, see here, if this is uprooted, it is plugged. So what will happen to the warm air? Will it rise gently or vertically? It is going to rise now vertically. See here. So this is how the warm air is going to rise. This is going to be more or less vertical, and the warm air will be uplifted forcefully from here. Why? Because it is the cold air which is picking this up, and the warm air, when it is uplifted vertically at rapid rate, what type of cloud is going to form? Cumulonimbus cloud. This is the cumulonimbus cloud is going to form. Cumulonimbus clouds are associated with what? Short duration rainfall, but comparatively heavy rainfall. Heavy rainfall, short duration, can also be associated with what? Because it is cumulonimbus cloud, then it can be associated with thunder. Yes or no? Hails. Yes. Lightning. Yes. So this is the cold front. Now, what is the characteristic of the cold? You can see the slope is vertical almost. Yes or no? Yes. That is cold front. How it is decided whether it is cold or the warm? The cold one means the cold is active and aggressive. It is invading the areas of warm air. Okay? समझ में आया? Now see here, what is the identification whether in your area the warm front has been formed? See here, if you are standing here, what you will see the signal in the upper atmosphere? Which cloud? Cirrostratus cloud. If it is forming, then you will understand what type of front it is. It is warm front is developing. If you are standing here and you can see vertically growing cloud, the darker one, that is the signal of which kind of front formation? It is the cold front has been formed. Okay? I think I should leave here. Now, आपका अच्छा मेरा, मैंने सोचा मुझे कह रहा हूँ. I wanted to extend, but now very much not tired. I'm going through fever. So yes, we are finishing here. Done.